lonely, and no one knew what it meant. These were the words from Sir Roger Tomlinson, who is the father of GIS. Let us start today's session, Implementation of GIS Technologies in Modern Development webinar, jointly conducted by Team 2020 Helpers India and Unique Mappers Team Nigeria. So in 1961, Rogers Tomlinson proposed a solution using computerized spatial data, and thus modern GIS was born. In the more than 50 years since, GIS has grown into a technology that can be applied in almost all disciplines, needing to understand patterns across space and time. So digital mapping is about to change our world by documenting the real world, then integrating the information inside our computers, phones, and lifestyle. Rollover, scored by space photography, global satellite positioning, GPS, mobile phones, search engines, and new way of marketing information for the World Wide Web. The ancient art of cartographer is now at the cutting edge. With a vast improvement of this technology, there is still a need of intense research and innovation to create a future with nowhere to hide. So let us gather a vital information from our speakers on these great technologies, Dr. Shivangi Somvanshi and Mr. Victor Sunday. Before handing over this session to our speakers, let me introduce the great personalities as the speaker of this session. Today's resource person is Dr. Shivangi Somvanshi, with an experience of 11 years in GIS field. She is working as an assistant professor at Amity University as a Geoinformatics and remote sensing professor. She is also working as a geospatial consultant, geospatial mapping and modeling, Noida, Uttar Pradesh, India. And our guest speaker, Mr. Victor Sunday, the lecturer and consultant of Geospatial Information Science, Department of Geography and Environmental Management, University of Port Harcourt, Nigeria. He is also a state coordinator in Geoinformation Society of Nigeria, GEOSON. So the profile of our speakers is very huge and very inspiring. Instead of wasting our time or taking too long in introducing them, I wish to hand over this session directly to Ms. Shivagami. Please, Dr. Shivagami, you can start your session.
Thank you so much, Moaz, for such a, I can say, a brilliant introduction. And really thank you to the team of your team 2020 Helpers for giving me this opportunity to speak on or to deliver a talk on such a budding technology, that is geospatial technology. I hope my screen is visible. My screen is visible, Moaz?
Yes, it is visible.
It is visible. Okay, thank you so much. Fine. So today I was about to talk about this budding technology, or I may say that the hottest technology in the current era right now, that is geospatial technology. And geospatial thinking is transforming the world, no doubt. Geospatial technology is unveiling a new era, and it is actually transforming the world. So this is the age in which human and machines come together, and we call it as the fourth industrial revolution. And it is characterized by the knowledge derived from data, network, and powerful tools. So many of the world's greatest challenges are, place and time related. For example, poverty and land rights, circular economy, climate change, sea level rise, renewable energy, and how we efficiently harness it, and protection against pandemics. So the defense sector has long recognized the value of geospatial knowledge, often calling it geospatial intelligence. So we'll be talking about this today. So let us see what is geospatial technology. So geospatial technology is a term used to describe the range of modern tools contributing to geographic mapping and analysis of the earth and the human societies. So these technologies have been evolving in some form since the first map was drawn in the prehistoric era. So the fact is, you actually know more about geospatial technology than you think. Geospatial technology is all around us. It's in our phones, it's in our car, on the news, in the video games like Woohoo Island and your Grand Theft Auto. So these are the few video games which are based on geospatial technology. So today's video games are much more different than that of our times. They are based on virtual reality. So when we talk about virtual reality, means we are actually taking into account the landscape, the topography, map, and merely spatial awareness. So spatial. Right now I use the term spatial. Now this is the keyword associated with geospatial technology. Spatial means location specific. So when you are linking every object with its location, and location in terms of geospatial technology means latitude and longitude. So geospatial technologies has almost become ordinary, and you are using it in your day-to-day life. Now, that whatever is happening around us, everything that happens somewhere. We are human. Our activities are largely confined to surface and near surface of the earth. Like we travel over it, we dig ditches, we create tunnels, we bury pipelines and cables, construct mines, we drill wells to access oil and gas. So keeping track of all these activities is important. Like when you are putting pipelines, it is very essential for you to keep a track of the location of the pipeline. Knowing where it occurs can be the most convenient basis for tracking. So geographic location is an important attribute of all the activities, policies, strategies, and plans. And geospatial technology keeps track not only of the events, activities, or things, but also where these events, activities, and things happen or exist. So here you can see that I have highlighted the term spatial information. So this is what spatial information is all about, where you are gathering the information about any object through its location. That means location specific information you're talking about. Now, the question is how to think geographically. Thinking geographically means looking for some solution of a problem which is location based. Some of these problems are so routine you almost fail to notice them, like a daily question: which route take to and from work, and which route have less traffic or shorter way to go, for which you mainly rely on mobile GPS. So in order to know which route should follow every day, you take a help of GPS app, which is there in your mobile. So which is actually a product of geospatial technology. Second example is while you are booking a cab using Uber and Ola, where you look for a cab near to your location. So these platforms are also the product of geospatial technology. Because location is so important, it is an issue in many of the problems society must solve. So these are just two of the examples I have mentioned here. There are so many examples which exactly clear the concept of geographic problems, which you are actually dealing with in your daily life. So the problem that involves the aspect of location, either in the information used to solve them or in the solution themselves, is termed as geographic problem. So here are a few more examples in order to clear the concept of geographic location or geographic problem, sorry. So the very first one is like a healthcare managers. They solve a geographic problem when they locate new clinic and hospital. So it is a location-based problem where a healthcare manager should locate a new clinic, in which area they should start with a new clinic or a new hospital. Then a delivery companies, They deal with the geographic problem while deciding the route and the schedule of their vehicles, often on a daily basis. Then transportation authorities, they select route for new highways. So where a new highway should be developed, which route is facing the traffic issue, so that new highway can be proposed in that particular area. So that's again a location-based problem. Forestry companies, like they deal with the geographic problem to determine how best to manage a forest, where to cut, where to locate road, where to plant new trees. So again, in order to take the decisions with respect to these problems, they deal with the geographic problem and they take the help of geospatial technology to solve these problems. Then travelers and tourists, they also deal with geographic problems, like giving and receiving the driving directions, selecting the hotels in an unfamiliar city. For example, booking a hotel on Make My Trip. You enter a location of your destination and it provides you the location of the nearby hotels in that specific area. So these are few of the examples of geographic problems with which you are dealing with in your daily life. And I hope these examples might have cleared the concept of geographic problems. So real world is very complex. And as far as geographic databases are concerned, they are often transactional. Means they are constantly being updated. A new information arrives, like a new road network. Like almost every day some sort of new road is being constructed. So these road network is being updated very frequently. Similarly, forest activities like deforestation is taking place, planting of new trees are taking place. So there are so many changes which are taking place within the forest with respect to time. So very frequently the changes are taking place, and hence the forest cover data or the road network data are being updated very frequently, which cannot be completely dependent on paper map, the historical paper maps, because the paper maps stay the same once they are printed and cannot be updated frequently. So in such case, geospatial technology is very beneficial, and here a system like geospatial technology pervades many aspects of our daily life. You can update the frequent changes of landscape very quickly and very easily using geospatial technology, which cannot be done on a paper map. Like nowadays, you are using Google Earth and Google Map, which are actually on a geospatial platform, and they get updated very frequently. Now, let us see some of the importance of geospatial technology, or you can say significance of geospatial data. Call it geospatial data or location intelligence. But why is geocentric technology so important? That's the question. Why? Because we are building and working on a digital representation of a real world. Now, think about this statement a little. And that word which is highlighted, that is digital. We are preparing the digital twin of the real world. Now, what is a digital twin? The fourth industrial age embraces automation, data interpretability, data exchange, and manufacturing technology. So digital twin technology lies at the core of this new industrial revolution. A digital twin is a virtual replica of a physical asset, process, or service. For example, Google Earth or Google Maps. So let me explain you with the concept of mental maps and conceptual maps. This the concept of a digital twin. So a mental map model. A mental map is an explanation of someone's thought process about how something works in real world. It evolves with experience. A mental model is a representation that a person has in his mind about the object he is interacting with. Mental maps are actually maps of the environment stored in our brains that reflects the amount and extent of geographic knowledge and spatial awareness that we possess. So let me explain you this with a very simple example. When we were kids at our times, there was no Google Maps. At that time, when we have to direct any of our friend to our house, we explain them the way to our house, like how we explain our, the directions to reach to our house. And we used to explain them through our mental maps, like go straight for a few kilometers and then you'll find a roundabout. You have to take left from there. After a few steps, you will find a temple and then you'll take a right from there, etc., etc. So that is a mental map, right? Whereas nowadays, if you have to explain or if you want anybody to come to visit to your house, you are not going to explain them like this. Why? Because we have Google Maps with us. We just enter the the address and it shows you the directions along with accurate measurements. That is conceptual model. That means we have evolved from mental model to conceptual model over a period of time. So a conceptual model primary objective of a conceptual model is to convey the fundamental principles and basic functionality of the system in which it represents. A conceptual model is the actual model that that is given to the person through the design and interface of the actual product with accurate measurements, dimensions, and locations. So Google Maps is a conceptual model which is through an interface, which is coming to you through an interface, that is the platform, the GPS platform, and with accurate measurements and dimensions and locations. So it is a digital twin of a real world. We are not dependent on mental models anymore. So all human activities are fundamentally geographic in nature, and I already told you that all the fundamental activities of human are geographic, like location specific, and geography is geography is the fundamental of all what we do. If that is true, the statement which I said that geography is the fundamental of all what we do, then you would presume that our digital world is also on the same fundamental foundation, like our business world, our customer relationship management, enterprise resource planning have all been built upon the geographic foundation. But guess what? They are not. They are not yet. So this means that our digital world is out of sync with the world we actually deal with. That's why we are dealing with so many geographic problems as of now, which are not completely transformed into a digital platform. And that's the need of the awareness about the geospatial technology and what all wonders geospatial technology can do, and it can make your life much easier. Geospatial data allow us to build a digital representation of the real world. Digital maps allow us to ask where-based questions. And the example, very good example of your day-to-day life is while you are booking a cab on Uber and Ola for commuting. What you do while you book a cab? You put your location where you are, you put the location where you want to go. And what they do, they find the location of the nearby cab. So the cab which is nearby to your location, that comes as a solution for you. And a cab is booked. Where you are, where you want to go, and the nearby cab, they are all location based. So your problem was also location based and the solution was also location based, and it is all on a geospatial platform. Now, geospatial revolution. New ways to collect, visualize, analyze geospatial data is at the heart of geospatial revolution. And thanks to the technological advances, we are now able to view and ask questions to our world digitally. That is the advancement of IT. That means existing IT systems are slowly being revoked as foundationally geospatial. Like what you can see out of your window, you can see the same in the digital world. You might have scrolled Google Earth, where you can zoom in and see your society, your house, etc. So which is exactly the twin of the real world scenario. So there is one more definition. Location intelligence is the process of deriving meaningful insight from geospatial data and relationships to solve problems. So location intelligence, LI, is how we ask question of the geospatial data to solve actual problems. So real world questions can be answered through a digital representation of your world. So this is the main significance of real world technology, and the real world geographic problems can be solved very easily through a digital representation of geospatial technology. Now, here are some of the examples of the industries where the geospatial technologies can be used or is being used successfully in different industries. Like for business, we can use geospatial technology for site location, delivery system, marketing. In government sector, we can use it for local, state, federal, military purposes. Economic development sector, we can use it for population studies, income, census, demographic studies. Emergency, like we've been using geospatial technology for developing forest fire or different kind of disasters right now. Then environmental, you can use it for monitoring and the modeling purposes of various environmental pollutions. Then transportation, communication, mining, pipelines, epidemiological studies. So during these pandemic times, you might have heard about geotagging of the areas. Which area contained more number of COVID cases, which area contained less number of COVID cases, and on the basis of that, they have divided it into red zone, blue zone, green zones, orange zones. So that is geotagging, which is again one of the advantage of geospatial technology. Then we use it in urban planning, mainly. Majorly, the geospatial technology is being used in urban planning to define the land use pattern, land use cover change, historic studies. Then in politics, while election and reappointment, we can use geospatial technology, and in education for research and teaching purposes, we can use geospatial technology. Now, let us talk about some of the components of geospatial technology. So within the realm of the geospatial information technology, there are three major components: remote sensing, geographic information system, commonly known as GIS, and global positioning system, commonly known as GPS. So we will be talking about a little bit about them, but I'll emphasize more on remote sensing. So geospatial technology is an emerging field of study that indicates all three components, that is remote sensing, GIS, and GPS. So let us discuss them one by one. So we'll start with remote sensing first. Remote sensing, as the name indicates, something which is being sensed remotely. So in order to collect any specific data, if you have to collect any data for research purpose, we have two options. First is to go to the ground or field along with your instrument and do measurements. These are known as in situ measurements or the field measurements or the ground truth measurements. And the other way out is to remotely access the data. So the process of remotely accessing the data or to observe an area or the object or the phenomenon through the analysis of data acquired by a device which is not in contact with the field is the process of remote sensing. So what is remote sensing? So here is the exact definition, that remote sensing is defined as a process or technique of obtaining information about an object, an area, or a phenomenon through the analysis of data acquired by a device without being in contact with that object, area, or phenomenon being studied. So if you are acquiring some information about any object without being in contact with that object, that means through some sensors. Now sensors can be ground based, can be air based, can be satellite based, but they are not in touch with the object. That is remote sensing. So when you learn some topic, any topic, so there are the three basic questions which comes to your mind: what, why, and how. So what is remote sensing? I hope it is already clear to you all. Now coming to why we should go about it. When we know that field measurements are more accurate. For example, if I want to know the temperature of your body, I will use a mercury thermometer, and that is an in situ way of measuring temperature, which will be more accurate. However, there are ways of determining the temperature of the body using remote sensing techniques also. So there are certain uncertainties associated with remote sensing. However, there are many advantages associated with these techniques. The very first one is systematic data collection. Simple to understand. Suppose I send 10 people on the ground to collect soil samples. 10 human means 10 different types of sampling techniques and 10 different types of errors also. So removing this subjectivity in data collection, remote sensing provide a systematic way of data collection in a particular fashion, in a particular orbit or path or road, and it has to be in a systematic manner. Other thing is getting the information about 3 dimensions of the real object. That's the second major advantage. I hope you all have scrolled Google Earth and might have observed that in several places 3D view is available. So this is again one of the advantage. Then repeatability, that is a very important advantage of remote sensing. When I talk about repeatability, I talk in terms of both space and time. That means you can cover the same area. You can come back to the same place after a few months, few days, or even after a few hours in some cases, or years. So repeatability is possible in case of remote sensing, which help us in collecting the time series data very easily. Then the next advantage is that we can have a synoptic view. We can have a global coverage using remote sensing method and see a larger area at the same time. So sometimes maybe there are the areas which we want to study are inaccessible. Let's say in case of a disaster where you cannot risk your life in going there and collecting the data or the information. At that time, remote sensing becomes the only solution. Then the next advantage is the same information collected using remote sensing technique can be utilized in several manners by its application by people of different fields. Like the same satellite imagery can be used by a person who is working in forestry department for their purposes, the person using it for water resources, for urban planning, for atmospheric sciences, etc. So different people of different field can use the same generated data as per their application. So there are many other advantages that can add on to these major ones. So geospatial technology or remote sensing, why remote sensing should be done, why you should prefer remote sensing over traditional methods of measurement, these are some of the major advantages. Now, having the answer to what and why, probably the next question to us is how. That is how we do remote sensing. So here is the complete process of remote sensing. First and the foremost thing we require is a source. Here, as you can see, A, that denotes a source. So a source can be artificial or man-made, or it can be natural source like sun. So here are 2 terms which are associated with it. If a sensor are designed to read the electromagnetic radiations coming from sun, we call it as active sensor, and the technique is known as passive remote sensing. If the sensor have inbuilt source of illumination, they have their inbuilt source of illumination like a camera with the flashlight. They have the inbuilt source of illumination. So these sources, be it artificial or like they are actually known as active sensors. These sensors are known as active sensors, and the process is known as active remote sensing. So these sources, be it artificial, be it natural, they provide energy in the form of electromagnetic radiations, EMR. And it is important to understand what we sense. We are sensing electromagnetic radiations. So if you see the electromagnetic spectrum, so here it is, the electromagnetic spectrum, from the higher wavelength to the lower wavelength, the depiction is as mentioned here. We have radio waves, microwaves, infrared, visible range, ultraviolet, X-rays, gamma rays, and cosmic rays. So for remote sensing purpose of Earth observation, we are mainly concerned with visible, infrared, and microwave range of electromagnetic spectrum. And on the basis of that, which radiation you are using, we have categorized remote sensing into optical remote sensing, thermal remote sensing, and microwave remote sensing. So there are the 3 different types of remote sensing. Now, this energy which is coming from the source, as as you can see here, the energy which is coming from the source, it illuminates the target. So here in this figure, C, which is denoted, the target is denoted as C. So now target can be any object on earth, like a tree, a pond, a built-up area, etc. So when the energy reacts or hits the target, there are the three forms of interaction that can take place when energy strikes the target. These are absorption, transmission, and reflection. Like some portion of that energy which is hitting the target get absorbed by the object, some get transmitted, some get reflected. And the part of energy that is reflected by the target is coming to the sensor. And in remote sensing, we are mainly concerned with the reflected energy. However, some part of the energy which is being absorbed by the object, after some time it is being emitted. Now that emitted energy is also being read by the sensor, mainly in case of thermal remote sensing. Right? Now, there is one term here which is associated is reflectance. Now, reflectance is actually the percentage of incident radiation which is reflected by the object. 100% energy is coming, right? Some portion, like 40% is getting absorbed, I mean 60% is being reflected. Now, this 60% which is reflected is your reflectance. So, every object, like in remote sensing, we usually talk in terms of reflectance value, and every object has their specific reflectance value. Tree will reflect differently in different wavelengths. Water body will reflect differently in different wavelengths. A clear water body will reflect differently, and a polluted water body will reflect differently. So, reflectance value of the object at different wavelengths help us in identifying the object on the satellite image. Now coming to the next component of remote sensing. So this reflected radiation coming from the object, once the energy is being reflected by the object, they are read by the sensors. Now the sensor has to be created or has to be carried by some platform. So it can be a ground-based platforms like MAST, it can be an air-based platforms like drones, UAVs, or it can be a space-based platform like satellites. So now, while the radiations are traveling from the source to the target, or from the target to the sensor on board, it interacts with the atmosphere twice. As here you can see, it is denoted by B. So while the radiation is coming down to the object and while they are reflecting back from the object to the sensor, they interact with the atmosphere twice. Now, what is there in the atmosphere and how these radiations behave when they interact with the atmosphere? So, our atmosphere, we have the particles, we have the gases. They are the two major things which are present in our atmosphere. Now, these particles and the gases in the atmosphere can affect the incoming radiation. Two basic mechanisms which are associated with the interaction and absorption are actually absorption and scattering. So particles which are present in the atmosphere, PM10, PM2.5, there are many particulate matters which are present in the atmosphere, they scatter the radiation. While the gases which are present in the atmosphere can absorb the radiation. So interaction of the direct solar radiations and reflected radiations from the target with the atmospheric constituents interfere with the process of remote sensing, and we call it as atmospheric effect. Now the next component, coming back, once the data is collected by the sensor on board, now this data is to be transmitted to the ground receiving stations, which is the next component, and that is component E. So once the data is collected on ground, it has to be stored in different formats and uploaded on data providers' website. Finally, the data which is coming from data providers can be used by different application groups. So application is actually the last component of remote sensing, which is denoted here by G. The final element of the remote sensing process is achieved when we are able to extract information from the imagery about the target in order to better understand it, or you can say reveal some new information or assist in solving a particular problem. So then only the target is being achieved, the remote sensing, or you can say the final element of the remote sensing process is achieved. So here I talked about some of the data providers. So you have the data libraries from different data agencies worldwide, and what they do, they collect the data, all that data which has been collected by the ground receiving station, they process it and then they upload it into the data libraries, and these data libraries are being managed by the national agencies also, like from different government agencies, or private agencies are also dealing with it. So these are some of the important data libraries from where you can download the satellite images, like you have USGS, that is United States Geological Survey. You'll find huge, it's a very huge library of data set, and you'll be able to download the images from there freely. And for Indian, you have GUVAN, which is being managed by NRSC, National Remote Sensing Center. Then you have GLOWIS, and you have NOAA. So there are so many libraries which are present from where this remote sensing data can be acquired and can be downloaded easily. So with this, we finished off with the very first component of geospatial technology, that is remote sensing. So I tried to give you some insight, although it's a very vast subject and it takes time. But I just try to give you in brief that how the process works and how the data is being collected, and then finally this data is being processed and can be used by different people for different applications. Now coming to the second component of your geospatial technology, that is Geographic Information System, GIS. What is GIS? Now, Geographic Information System has different definitions with respect to different users. Who is using? So if I talk in terms of a layman language or a general public who is not from a geospatial background, for them it is just a container of maps in a digital form. If you say GIS, they'll say, okay, fine, I think Google Earth. This is what they know, it's a map, or Google Maps. That is what they know about GIS, that's it. Then maybe for decision makers, it's a computerized tool for solving geographic problems, like for urban planners, which have to develop some policies with respect to sustainable urban management. So in that case, for them, it is just a tool which can help them in developing the policies or solving the problems with respect to sustainable urban sprawl. Then for a management scientist, operation researchers, it can be a special decision support system. For utility managers, like for those who are laying the pipelines, or transportation officers, or resource managers, for them it is a mechanized inventory of geographically distributed features and facilities, because they are more concerned where to lay the pipelines. Then for scientists and investigators, the tool for revealing what otherwise is invisible in geographic information. So here comes the real definition. Invisible becomes visible. Then resource managers, planners, a tool for performing operation on geographic data that are too tedious or expensive or inaccurate in performing by hand. So geographic information system has a very wide variety of definitions. Every person has their different perspective of GIS, but technically GIS, Geographic Information System, is a computer-based information system designed to accept large volumes of spatial data derived from a variety of sources and to efficiently store, retrieve, analyze, model, and display these data according to user-defined specifications. So it is basically a system devised to work on or to manage spatial information. Again, the term spatial is of huge importance. Spatial, anything which has a spatial contact can be studied or analyzed using GIS. So GIS is a computer-based system. Google Earth, for example, can be considered as a nice symbol of GIS software package. Then, what are the different components of GIS? Now, GIS comprises of 5 components. There are 5 things which are involved, which together forms the GIS system. So the very first component is hardware is a computer on which GIS operates. So today, GIS software runs on a wide range of hardware types, like from centralized computer servers to desktop computers used, in standalone or network configuration. So hardware. The second major component is software. GIS software provide functions and tools needed to store, analyze, and display geographic information. Initial GIS works on old operating systems like Unix, but now recent GIS software work on Windows machines with very powerful tools, and most of the tasks you can think of can be performed using such kind of GIS software. Software we commonly use is ArcGIS. ArcGIS is produced by a company called ISRI. So they are #1 producers of ArcGIS software. Then the third component of your GIS is data. So data is possibly the most important component of GIS. And which kind of data I'm talking about? I'm talking about geospatial data. And geospatial data is either in the form of vector or in the form of raster. Then the next is your methods. That's the next component. So different methods are applied on data. Now the data, you have a data, and in order to get an output, you need some sort of methods to be applied on it. So those methods like data input, data manipulation, data analysis, data output, everything is performed on a GIS software, and they are embedded in the form of algorithms and represent as GIS tools. So every software has some tools, and by applying that tools, you can in the form of algorithms, you can process the data. And the last component of GIS is people, the people who are working on GIS. So people who are associated with GIS as GIS developers, GIS experts, GIS analysts, end users of GIS, and different decision makers who are using end products developed by GIS for developing policies. They also form the last component, or they also form the part of the GIS system, that is Geographic Information System. Now there are a few important and commonly used softwares, GIS software. Some are licensed, some are open access, and the most commonly used, as I told you, is ArcGIS. So you can see ISRI ArcGIS, you can see ERDAS here, QGIS. QGIS is open source and very good software. And you have SNAP, which is mainly for your Sentinel data. Then the third and the last component of geospatial technology is global positioning system, that is GPS. So GPS is a global navigation satellite system that provides location, velocity, and time synchronization. So GPS is everywhere. You can find GPS system in your car, in your smartphone, your watches, and GPS help you get where you are going from one place to another. So the global positioning system is a navigation system using satellites, a receiver, an algorithm to synchronize location, velocity, and time data for air, for sea, for land travels. And satellite system consists of, in case of GPS, there is a satellite system which consists of the constellation of 24 satellites in 6 Earth-centered orbital planes. There are 6 planes, and each plane has 4 satellites, like 4 satellites orbiting at around 2,200 kilometers above Earth and traveling at the speed of around 14,000 kilometers per hour. While we only need 3 satellites to produce location on Earth's surface, a 4th satellite is often used to validate the information from the other 3. Then GPS is a very powerful and dependable tool for business and organization in many different industries. Surveyors, scientists, pilots, boat captains, then first responders, and workers in mining and agriculture are just some of the people who use GPS on a daily basis for work. So they use GPS information for preparing accurate surveys and maps, taking precise time measurements, tracking position or location, and for navigation. So GPS work at all times and in almost all weather conditions. And some of the main uses of GPS is to determine a position, a location. What you do when you use your GPS on mobile, you look your location, right? So it helps in determining the location. Then navigation, that is getting from one place to another. It helps you in navigating, tracking, monitoring the objects or personal movement. then usually the police department, they try to track your lost mobile using GPS. So that is again monitoring the objects of the personal movement. Then creating maps of the world, mapping, we use it for timing, like making it possible to take precise time measurements through GPS. So with this, we finished off with all the three components of geospatial technology. And lastly, I want to discuss one case study of GAUTAM NAGAR to demonstrate you the power of geospatial technology in urban planning, specifically in urban planning, where you can predict, you can forecast. Now here in this image, you can see how gradually the urban settlement increased from 2001 to 2016 in the Noida and the Greater Noida areas of India. The portion which is highlighted in red is showing you the urban build-up, and over a period of time you can see the density of this red color is increasing and the urban build-up is increasing. Now we know that there is the increase in the urban settlement. We know that, like you can see it visually. But which class is converted into urban settlement? Like how much how much amount of agricultural land is converted into urban build-up, or how much area of rural build-up is converted into urban build-up, or how much amount of wasteland is converted into urban build-up. Here again, the GIS is emerged as a powerful tool to calculate the conversion. So here in this slide, through map and through tables, we can see the conversion. As in the table, you can see that around 136 square kilometer of agricultural land was converted into urban build-up from 2001 to 2016. Similarly, around 233 square kilometer of rural build-up is converted into urban settlement. So this is again one of the very powerful tool of GIS, that you can, over a period of time, using historical data, you can calculate that how much amount of area is converted into which kind of class. Then this slide shows the simulated or the predicted map of the same area for the year 2031. So also the statistics in the table. So here we use the machine learning algorithms to for the prediction using geospatial data. And the observation received from such kind of study based on the long-term classification of satellite data, statistical methods, and other geospatial technology indicates that the predicted land use land cover map of the area will be precious information for policy and decision makers for sustainable urban development and natural resource management in the area for food and water security. So these are some of the powerful tools which can be implemented in different fields. Like here I have just given you one example of urban planning. It can be used in different fields exponentially, and which is really very difficult to do it. If you actually go onto the ground and try to calculate, it is very difficult. So in the end, I would like to conclude that geospatial technology broadly includes mapping and surveying techniques, remote sensing, photogrammetry, cartography, global positioning system, geographic information system, with its unique ability for acquisition, integration, and analysis of geographically referenced spatial information. This technology has in recent times been recognized as an effective tool for planning, management, and decision making locally and globally. And geospatial technology has made inroads across various sectors, like in the public as well as in private domain worldwide. And the major sectors using geospatial technology are agriculture, telecommunication, oil and gas, environmental management, forestry, public safety, infrastructure, logistics, etc. And as stakeholders across sector, they realize the utility and long-term cost effectiveness of using geospatial tools and technologies, and the geospatial industry is set to progress by leaps and bounds in the coming years. So with this, I would like to conclude my presentation. Thank you so much. Over to you.
Thank you very much, ma'am. Yes, I want to thank you very much mean, I'm getting my voice in echo. So, am I audible?
Yes, yes, you're audible.
Yeah. So, thank you very much, Dr. Shivangi, for this great explanation of the special information. I hope our young attendees have understood the importance of innovation in GIS for solving geographic problems. Also, significance and application of remote sensing technology were well interpreted in simple and easy to understand slides. It was a pleasure for us to get these useful insights of information technologies from you, ma'am. Once again, thank you. And now I may request Mr. Victor to please bless us with sharing some of his expertise of GIS technologies. Please, sir. Mr. Victor, if you are
My green screen now.
yes, sir, your screen is available with us.
Oh, okay. Thank you very much, and thank you, Dr. Shavinga, for that wonderful
Please, there will be there is a
first
hide
section.
button in the
We'll
pop-up.
be going to
You
look
can
at the
hide
power.
this pop-up so that you can see your full screen.
I didn't get you. Hello? Hello? Can you see my screen?
Yes, yes, it is visible.
Can you see my screen clearly?
Yes, it is visible. You can go ahead, Victor.
Yes.
Okay, thank you very much.
Ahead, sir.
Okay, thank you very much. Yeah, so we continue with the second section on the power of OpenStreetMap in building a career in GIS. And we are sharing this as part of the process of implementation of implementing GIS technology to drive modern development. And briefly, I'll just talk about OpenStreetMap and then importance and demand of GIS in the coming future. These are future already here with us. And we'll talk a little on how to start a successful career in GIS. OpenStreetMap currently is widely known, and it was created by Steve Coast in 2004. Is a free editable map of the world, which is community driven. And as a result of that, you could see that everyone that engages in OpenStreetMap would have a connection to GIS. Here, we are looking at OpenStreetMap as a desktop GIS, as a web GIS, where everyone could come on board and then have the practical skill of digitize, find out that it gives you opportunity to capture data, and then it gives you opportunity to update data. It gives you opportunity to store data and also data. So when you look at what the concept of GIS and GIS does when it comes to geospatial data, and then you look at the database of OpenStreetMap that is community driven, you find out that it you need to find another thing on web platform. That is mapper with OpenStreetMap. Well, for anyone, irrespective of his or her background, for you to be a GIS mapper with OpenStreetMap, a contributor with OpenStreetMap, you need to go and sign up for a username at www.openstreetmap.org, and once you sign up for a username, that gives you access to the database. Another thing you can do to become an active OpenStreetMap contributor is to join a local community, and that really also helps to improve your skill. Since OpenStreetMap gives you a base map to work with, it also gives you opportunity so that this base map could now have could be integrated, could have an interface in your QGIS, so that you, with your QGIS OSM with your QGIS OSM plugin, you could have access to your database, your OpenStreetMap database, and you are able to extract data. You're able to further your analysis. You're able to do further your visualization and so on. And then you have the OSM mobile data collection tools, the hot taxing manager, the Teach OSM platforms that helps you, that gives an engagement or provides an engagement for those who are aspiring to become GIS professionals, GIS analysts, GIS technologists, and so on. So all these mapping tools with OpenStreetMap gives everyone the opportunity to get exposed to the career of GIS. And so OSM could actually be a basis, could actually provide a platform or a linkage for anyone to build his career or her career in the field of GIS. And so OpenStreetMap is a credible alternative to proprietary maps, because you could actually capture near instant updates with the community being engaged and so on. And not just that, we can say that no map is perfect, but the main thing is that with OSM, people are editing it because they enjoy it. And that is also one aspect that would actually help anyone that wants to build his career around GIS. Do you enjoy capturing geospatial data? Do you enjoy playing with geospatial data? Do you have passion, to think geospatially and so on? Do you have passion to analyze features on the from the Earth, that capture from the Earth surface? So once there's passion that comes along with that, then you find out that you are good to go. And so the offshoot of is that you will get more data, you will get more output from GIS analysis connected to OpenStreetMap when our volunteers from volunteers of OpenStreetMap more than even paid staff. That is to say that anyone that volunteers in participating in OpenStreetMap actually would be having a competitive experience with any other GIS person that is paid or that is already employed. And so when you are engaged with OpenStreetMap, it gives opportunity to build your career linkages, because in OSM, OSM is community driven. OSM is connected to area map, connected to remote sensing data, because the data that is being uploaded, the satellite images that is being uploaded to OpenStreetMap platform are being captured through remote sensing data process, remote sensing data capture process, and then it has low-tech field maps and so on. Local knowledge is applied, and then it gives opportunity for mapping specialists to come around together. It also gives opportunity for GIS professionals to actually drive their professional targets and so on. It also engages engineers, that's the developers, software developers around the OpenStreetMap. And so it is an epicenter, it is a focus, it is a platform that can actually provide linkages for those who are building their career in GIS. And so what are the importance or the demand of GIS in the future? One of the things, just like Dr. Shivangi mentioned, is that of critical spatial thinking, geospatial thinking. And so, as much as there's continuous quest for critical spatial thinking, driving people into learning how to think spatially, you find out that there will be high demand for GIS specialists, not just presently, but in the future. And as you can see, with the post COVID-19 pandemic research, analysis, and so on, you discover that there is a critical spatial thinking of the effect of the COVID-19. And so those spatial thinking has to be analyzed through GIS capture of data, analysis, and so on. What about the 3W of geography? That is what, where, and why, or even when we say the 5, which includes who and when, especially where we need to ensure that everyone is counted and no one is left behind. If that is to be done, that means that geospatial data need to be captured, and if it is to be captured, then someone need to be there to ensure that as much as it is captured, it is analyzed, it is also processed, it is geo-visualized, and then it will help in decision making. There will be high demand for GIS in the future, as much as there is need for critical geospatial data acquisition that will drive a measurable target of the SDGs beyond 2030. All the 17 goals of SDG actually need a measurable need to be driven by a measurable target that is driven by critical geospatial data that is acquired, analyzed, and also visualized. And so there is need for GIS professionals, GIS analysts, and then because you cannot just provide a measurable target of any of the SDG without spatially thinking about, how you have actually driven that particular goal. You're talking about zero hunger, achieving zero hunger in a particular location. So how many households do we have there? To what extent are they receiving to what extent are they receiving are they comfortable with the food supply chain and so on? During the COVID-19 period, palliatives were released here and there across different nation communities over the world because of the lockdown and so on. And then that was to drive zero hunger SDG. But you find out that in as much as this there should be a measurable target of this particular SDG, they cannot be achieved without critically providing geospatial data that will prove that such targets are being met. Another thing is the real-time data collection. Hello.
Yes, you are audible, Victor.
Okay, I hope you are still seeing my slide.
Yes, your presentation is also visible.
Oh, okay. Yeah, so the next one is real-time data collection, which also connects with Cloud GIS. That is also what is, pulling everyone around the GIS, and then also creating a high demand for GIS, even as we look ahead into the future. Real-time data is very, very critical for every organization. Is it in the logistics? Is it in the health sector? Is it in engineering, environmental, and so on. Real-time data collection is quite critical. And then because GIS is connected or integrated with the cloud computing that is going on, is connected with Internet of Things, and also you can see the integration of artificial intelligence. You find out that the importance of GIS cannot really be overemphasized with as the future, is being driven towards sustainable development target. What about open source GIS? Currently, you see everyone wants to talk about open data, and with open data, we're talking about data science. And when we talk about data science, we're talking about geospatial data science. And so all of them are interconnected so that you can have high demand for GIS professionals, high demand for GIS analysts, high demand for GIS personnel, and so on. And when you have open source maps, that also gives you opportunity, to access maps, access data that you need to work with in order to drive your company objectives, in order to drive your company targets, and so on. The 3D video visualization is another area that is actually, driving also the high demand for GIS in the future. And with that, you could see that data acquisition and analysis is an area where anyone could really see prospects with GIS career. Spatial data analysis and then visualization. What about software development and so on, and even remote sensing and so on. So we discovered that all those areas helps everyone to crave or to see how they can move into GIS career. And then how do you start a successful career in GIS? The first of all, and fundamentally, there's need for you to acquire an educational training in GIS, so that will give you the basis, that will give you the knowledge, they give you all it takes for you to really drive in. There's also need for professional training. You have all this professional certification training like this one we are engaging everyone presently is a professional training, so that you can have an update of what you need to know with respect to GIS as a career, or with respect to GIS as a profession. But once you have your GIS educational training, maybe as a geographer or any other basic discipline, and then you want to move, you can move to masters, you can move to PhD, and then your professional training as a GIS, as someone who really wants to go into GIS career, is very critical. Then GIS career space, you need to identify your GIS career space. And when you identify your GIS career space, you need to look at 3 different areas. Where are you looking at? Are you looking at exploring mobile GIS, and then making sure that you use them to solve problems in the society? And that is to say that you'll be very conversant, you are very good in using mobile data collection tools. And when we talk about mobile GIS, we are talking about integrated software and hardware framework that gives you access to the spatial data and services, through mobile devices. So that with your smartphone, you can go to the field, and as you are collecting your data, you are uploading to a platform, you're uploading to a device that will help you to store it, that will also help you to analyze, and also help you to drive your geovisualization. What about your desktop GIS? You need to be very conversant about your desktop GIS. You have your QGIS, you have your ArcGIS, you have your open source GIS, you have your proprietary GIS, and so on. And then they are desktop GIS because you work with them on a computer platform where they are being installed. And then you need to also be conversant with your GIS software in terms of the data-driven aspect. That is, are you using it for raster data analysis, or you are using it for vector-based data analysis? So we can have a raster-based GIS software. We have a vector-based GIS software. We can also have, like I just mentioned, your open source GIS software, and then your proprietary source GIS software. And then what about your web GIS, the cloud that connects to AI and then connects to OpenStreetMap and so on? So you need to identify your career space in terms of area of specialization, in terms of area of application. Are you applying GIS in transport and logistics? Are you applying GIS in disaster management? Are you applying GIS in plant ecology? Are you applying GIS in environmental areas, environmental management? Are you applying GIS in engineering? So you need to identify your career space where you are going to capture your data, or where you have passion to drive GIS exploration in. And once you identify your GIS career space and you begin to build on it, you find out that you are already on your way to a successful GIS career. The next thing you need to do is to find an internship. You need to go for it. Very, very important, because when you are engaged with an internship program, it gives you the opportunity to learn more. It gives you the opportunity to have hands-on, experience that will actually put you into practical application of GIS. And then the next thing you need to also, avail yourself is to volunteer. Volunteerism is very, very powerful, because when you volunteer with OpenStreetMap, local community, you volunteer with any organization, and then as you volunteer as a GIS mapper, you find out that it gives you opportunity to actually be engaged with definite tasks that will help you to analyze, that will help you to capture, that will even help you to explore the GIS softwares that are available. And then you should be able to serve and provide service. It is in serving to solve problems and using GIS that you will actually see yourself being competent enough to handle any GIS solution-driven. Yes, thank you very much for giving me your time to this brief about the power of OpenStreetMap in building a GIS career.
Thank you so much, Victor, for giving us insight on this. Thank you so much.
Thank you very much, sir, for these insights of your unique mappers team, and also the OpenStreetMap. You all are doing very, very great work, and I think in some part of the presentation of Mr. Victor, we got some audio lag. I apologize for this network issue, and Mr. Victor was very busy in his field work till yesterday. He was traveling, and still he managed to join this session. That's why this kind of issues had happened. So it was very good information provided by you, sir, on how to start a career in GIS. It will be very useful for our young enthusiasts who are willing to join GIS technologies field and work in this domain. So I thank all of you being the participants of this event and also the speakers of this event for making this event a grand success. We Team 2020 Helpers are a non-profit organization from West Bengal, India. We are intended to brought forward this kind of rare technologies which are not being accounted in a good way how it should be. Because just take an example of this GIS technology. This GIS is a very important aspect of life and a very important field of research for development, especially for these developing countries like us, India, Nigeria, and all other countries. But still, many people will not, most of the people are not aware of this topic. And with this intention of making this GIS, we have brought forward this event. And we hope and we assume that this will give a good impact on the students who have attended this event. And also, please fill the feedback form with your valuable feedbacks. It will be useful for us to plan or to plan our next events. And thank you very much, Shivangi. Thank you very much, Mr. Victor, for all your presence. So thank you very much, everybody, for joining this event. And I'm very glad you all have attended this event. And stay safe, stay connected, and keep learning from Team 2020.